kind of stuck. Okay, folks, I am going to go ahead and get started. I'm trying to figure out how to get rid of that screen issue. If I can't, I will just be careful to write on only a portion of mine. So first things first is I want to right folder. Starting today, I will be having you, other than on test days, it's obvious. But starting today, I will have you sign it on a sheet. Basically, you'll sign your name beside your name. And then what I want you to do is I want you to pass it down this grouping. So all the way through here and then over and then all the way back up. Okay. Second thing I want to mention is I have actually written your exam. And I am going to give you insights. So first thing is I will not be here on Friday for your exam. Dr. DeRocher will be proctoring the exam. But what I'm about to describe is how I expect you to do what I expect you to do every exam. So the very first thing is I expect you to basically be 3 per section with a chair in between. So like I said, 3 per section with a chair in between, 3 on each row with a chair in between. Now, if you don't have to be, but that's if there are 3 people in a row, I expect a chair in between. Secondly, you will have your cell phones off or on silent during an exam. No cell phones will be allowed out on the desk. They will be placed in your backpacks or with your stuff, and your stuff will be placed on the outside walls or the back wall. The only thing you're going to be allowed on your desk is a pen or pencil, a calculator, and I will allow food and drink. Again, I know it's at lunchtime and I don't need you passing out. Dr. DeRocher will then pass out and he'll go over these statements again. Then he'll pass out the exam. When he does so, the last page I want you to remove. The last page contains your formula sheet and it also contains your periodic table. When you turn in your exam, I do not want that page back. I want the other pages back, but not that one. Questions about the process. When you're done with an exam, you turn it in and you can leave. Now, on to the exam. Even though I went over this on Friday, I will go over it in brief today. There is a table that you have to complete about the subatomic particles. So you have to understand the subatomic particles. There are 2 average atomic mass calculations. There is a question about the most common isotope of an element. And there is a question with number 5 has 3 parts, but it's another question. It basically means you have to understand isotopic symbols like I went over on Friday. Question 6 through 13. You will be given a blank periodic table. Like it's just a small periodic table. And you are to answer questions about the periodic table's arrangement. Read the questions carefully, because on some questions I ask you to write the elemental symbols. On other questions, I ask you just to shade it in. Finally, question 14 there will be 5 different isotopes of elements that you have to answer the element symbol, the element name, the number of protons, neutrons, electrons, atomic mass, mass number, and isotope symbol. And that, yes. Element symbol, element name, number protons, number neutrons, number electrons, atomic number, mass number, isotope symbol. And folks, that is the exam. You have to show your work on calculation of the average atomic mass. It is potential that you will get partial credit. Such as, what is their charge, where are they located, and what are they responsible for? Other questions? Okay. Then the next thing I'm going to do is I am going to pass back quiz 1, quiz 2, and the one bonus I have received. Let me get me all lined up so that I can do this. Travell Anderson, Ashton Berry, Mahogany Blackman, Logan Campos, Jillian Chalfont, Madeline Connolly Hojas, Maddie Connolly Hojas, Madison Cordell, Casey Davidson, Macy Faust or Faust? Faust, okay. Got it right the first time. I should trust myself. Elijah Hoots, Elena Hutchison, is Elena or Lana? Alana. I went with my aunt's spelling name, the way she says it instead of, and I shouldn't have. Kelsey Jefferson. Haley Johnson. Abigail Kirkland. Adam Koch. How do you say it? Okay. Yay. Katie Miller. LeVay, no. And I'm gonna brutalize this one. Kuenga. Robert Ricks the third. Aisha Sankin. No, I'm brutalizing it. Say it again. Aisha Sankon. Okay. So say it just like it's spelled. I just didn't do it. Julie Snyder. Madeline Stovall. Olivia Swan. Abigail Thompson, or excuse me, Abigail Thomas. Jayla Thomas. Brecken Waters. Divion White. Will Wooten. Okay. Make sure you sign the sign-in sheet, because if you'll recall, you have attendance points, and from now on, that's how I will be determining attendance points. If you don't have your name signed in, you don't get, you're not going to be counted here, and therefore, instead of 1 point, you'll receive a 0. So, how can I get rid of that thing? It just does not want to go away. Okay, I'll just try to keep it very small. Okay, so the material being covered today begins the next exam. As I mentioned on Friday, the reason for that is because your first exam is pretty much all about the atoms of the elements. This next exam starts talking about compounds. And there are 2 types of compounds we will deal with. The first is what is called an ionic compound. Ionic compounds contain ionic bonds which are an electrostatic attraction. Between cations and anions. Now, yes, you're going to hear different ways of saying this, and I've looked it up to try to make sure I'm saying it the correct way. But you will hear people say cation. But I always use the term cation. And the reason I do so is because it is an ionic bond of cations and anions. Now, an ion, let's start with that, is simply a charged particle or charged element or polyatomic group, as we will discuss as we go. And that word is just between, that's hidden. I forgot to not go too far. Otherwise, it's there. The cation is specifically a positively nope, that's wrong. Positively, nothing is looking right today, I declare. Charged cation, charged element. Leave a space. We're going to come back to that statement. Anions are negatively charged. Elements or polyatomic groups. Now, folks, your cations, other than a very small handful of polyatomic ions, your cations will be metals. And if we're talking about elemental anions, they will be nonmetals and metalloids. So, one of the reasons you have to know the divisions on the periodic table is to know whether they will be a cation or whether they will be an anion. So just to remind everybody of this division: boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine are your metalloids. Boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine are your metalloids. Those elements can form anions. Along with any element to the right of that grouping, which are your non-metal. Everything to the left of that line are metals. So the majority of the periodic table are metals. That's one reason you have to know that division. Because you need to know, is it going to be a cation or is it going to be an anion? Now, your cations are formed when a metal loses electrons. For example, sodium metal, which is a solid, that's why it is black up there, will lose an electron to become sodium ion. Magnesium, element 12, it loses 2 electrons to become magnesium ion. Aluminum can lose 3 electrons to become aluminum ion. One thing to note is, one thing I want you to note is when a charge is not shown, it means that that element has no charge. And if you will look at each of these, that arrow would mean equals. And what you will see is it's a -3 on the electrons here, because there's 3 negatives, and a +3 on the aluminum. So you'll notice that that the 2 sides are equivalent in charge. When writing an equation for the formation of a cation and for the formation of an anion, the 2 sides will have the same overall charge. Questions? That is just showing that the 2 sides, so the 0 came from the fact that aluminum, because there was nothing showing on it initially, that means it has a 0 charge. The sign, the arrow, one of the ways to think about an arrow is it can also mean equals. Oops. I just realized part of the problem. The -3 came from the fact that there are 3 electrons that have a negative charge, and then the +3 came from the aluminum. So they should be equivalent on the 2 sides. Now, since we're talking about our cations, who loses what? And we're going to bring in another set of divisions up there. Group 1 metals will always lose one electron to make a +1 cation. Group 2 metals will always lose 2 electrons to make a +2 cation. The rest of it, of the elements that always form the same charge, form a nice little staircase on the periodic table. It's Ag, zinc and cadmium, and aluminum, gallium, and indium. If you look onto the periodic table, basically what I did is I made a stair step starting with element 47. Silver, whoops, can't put it there because I don't have enough space. Silver always forms a +1. Zinc and cadmium always form a +2. And aluminum, gallium, and indium always form a +3. Now, I like this because how many elements are in the same step as silver? Just itself. It's all by itself. It forms a +1. So one element in that step, +1 charge. How many elements make up the next step? 2. They are both a +2 charge. How many elements make up the next step? That's why they're always a +3 charge. So what I'm trying to do is help you memorize the elements that always form the same charge. And I just said something super important in that statement. And basically that was these elements listed above always form the same charge in an ionic compound. So before we move on to everybody else, let me just ask you some questions. If I gave you sodium chloride, what's the charge on the sodium? It's in group 1. It's element number 11. It's a +1. So in that compound, that sodium is a +1 charge. We don't always write the number if it's only a 1. If I gave you ZnOH2, what charge would you tell me zinc has? It's a +2 because it's always a +2. Now, let's talk about all other metals. When I talk about all other metals, I'm talking about the majority of transition metals. And the metals in the higher periods found in groups, or I should say main groups, main group elements. Of 13, 14, 15, 13, 14, and 15. All other metals form cations of different charges. For example, iron, which is Fe. Fe has the option to form iron 2+ plus 2 electrons, or it can form iron 3+ plus 3 electrons. Chromium it has the option to form chromium 2+, chromium 3+, chromium 6+, and those are its most common. So let's just revisit the things discussed thus far. Cations result from what? Loss of electrons. What type of element? Metals, nonmetals, or metalloids will lose electrons? Metals, and metals only. Some metals always form the same charge. Who are they? Silver, zinc, cadmium, gallium, aluminum, indium. Read above that. Before I started the stair step. Group 1 and group 2. Those will always form the same cation or the same charged cations. It doesn't matter what compound they're in. Sodium, I gave you the example of sodium chloride, but I could have also given you the example of, where did I put sodium chloride? There. I could have also given you the example of sodium oxide. And it would have still had the formation of sodium ion as a +1. We'll talk about that subscript more later on. I'm just saying that these elements always form that charge, no matter who they're combined with. Now, besides the main group metals in the higher periods, what other metals tend to form charges of varying that vary? I think I heard it. Maybe not. Besides the main group metals in the higher periods, what other metals tend to form charges that can vary? Transition metals. I'm going over that because, again, this is one of those periodic table differentiations that you need to know come test time. Your main group elements are the ones that are higher up, group 1, and I'm talking taller on the periodic table. Group 1, group 2, group 13 through 18. That's the main group. So when I said main group metals in the larger periods, I was talking about these down here, or in the higher periods. The transition metals is group 3 through 12. All of these at the bottom are your inner transition metals. So we're not even going to talk about those any more than what element is this? What element would this isotope be? But as far as compounds, we're not going to talk about these inner transition metals. We're going to stick with the main group elements and the transition metals. Trying to remind you of terminology
Mhm.
because it is crucial. Okay. Let's talk about the anions. Anions form from the gain of electrons to make negatively charged ions. And I finally spelled it right. It just took me a while today. Nothing was looking right. Now, these are going to be, again, your nonmetals and metalloids that can form anions. Your group 15, nonmetals and metalloids. Will have a -3 charge. Your group 16, nonmetals and metalloids, will have a -2 charge. And your group 17, nonmetals and metalloids, better known as what from the very first day? Better known as the halogens. Will always carry with them a -1 charge. So for example, nitrogen, and I'm using this terminology, nitrogen gains. So it is a +3 electrons to make N3 minus. Sulfur gains 2 electrons to make S2 minus. Fluorine gains 1 electron to make F minus. Again, the reason I knew these numbers here was because I paid attention to what group the element was in. And that's how I knew how many electrons it would add on to it. Because if it's group 15, it's going to be 3. If it's group 16, it's going to be 2. If it's group 17, it's going to be 1. And your noble gases, which are the only thing we haven't talked about, they don't do anything with respect to ionic compounds. Neither does boron, carbon, or silicon. Or germanium. None of those do anything with respect to ionic compounds, which is what we're talking about here. Okay, I know I talked a lot today. But I'm trying to prep you for what we will be doing on Wednesday, the Monday after the exam. And then what we're going to be getting, and then we're gonna get in polyatomic ions, and then we're finally gonna make the ionic compound where we bring these ions together. But we're gonna get down, we gotta get these ions down first. And so all I've done today is introduce this concept of what an ion is and how it happens to come about. And if you will notice, what's the only thing I touched when talking about the ions? Let me rephrase, what subatomic particle did I touch when we were talking about ions? Electrons, because electrons are responsible for what? The charge, which is, and its reactivity. I never touched the protons. You never saw me bring out the term proton today. That is because the protons are not involved in making a compound. Only the electrons are. And so I just want to emphasize that because that's going to be a common storyline in all of these. What we're going to learn on Wednesday is how to name all these things. And we are going to practice it. What we're going to learn Monday is how to name all the anions. And we're going to practice it. We're going to get into the polyatomic ions that day. And we are going to continue with polyatomic ions. Now, again, the material I'm going over is not on this exam, it's on the next exam. But it is on the homework that is due on tomorrow. What I went over today is on the homework due tomorrow. So that is important to just be able to pick those things up. Any questions? Okay, I will take your name kits and I will see you on Wednesday. I will be here Wednesday, just not Friday. I make sure that you have test days on the days I can't be around, and that way I'm always the one lecturing, at least.